welcome to Virtual Science. Today's content is about Heisenberg uncertainty principle. Before going into quantum mechanics, I am telling something on classical concept. In classical physics, if the initial position, velocity of the particle and force acting on the particle is known, then we can measure the physical parameters at any time accurately by using Newton's second law. Now, what Newton's second law states? It states that if a particle of mass m is moving and with an acceleration a, then the force acting on it is f, and this is related by f equals to m multiplied by a. Now, in that means the classical physics is deterministic. And does this hold good for quantum microscopic world? No, because microscopic world is associated with quantum mechanics and particles are treated as wave in quantum mechanics. As wave cannot be localized, so microscopic world is not deterministic. Now, in quantum mechanics, Heisenberg uncertainty principle, also known as uncertainty principle, is a mathematical inequalities between two measurable physical parameters. And this states that delta p delta x equals to h squared by 2. That means if we want to measure the position and momentum correctly at a same time, we can't measure it. Where delta p is the error or standard deviation and delta x is the standard deviation of position, delta p is the error in momentum, and these error in quantum mechanics are called uncertainty. So as the particle in quantum mechanics is very teeny, then their slight error is very affected to the original or accurate value. That is why we are very much conscious about the error or uncertainty in quantum mechanics. Now, if we want to measure the position and momentum of a particle at same time with very accuracy, then their accuracy level is not same, and this accuracy level is determined by these inequalities. That means this states that delta p times delta x always greater or equals to h squared by 2. This is the famous Heisenberg uncertainty relation, and there is another relation about time and energy. If we want to measure energy and time at a single time at a same time very accurately, then we cannot measure it. Similar to the following this equation, and delta E delta T always greater or equals to h squared by 2. There is a general rule for finding the uncertainty, and this states that if A is a physical quantity and B is also a physical quantity, and they are you want to find out their uh, accuracy level at the same time, that means simultaneously, then the error of A, that means delta A, or uncertainty of A, and error of B, that is delta B, and this holds this equation. That means delta A delta B always equals to 1 by 2i AB commutation average. Now if A and B are non-commutable, that means if AB non-zero, then there must be a finite value of delta A delta B. That means if A and B are non-commutable, then we cannot measure A B very accurately. Very measurement of a parameter very accurately means their error, that means delta A tends to 0. So this equation is very common equation and very useful for finding the uncertainty between two physical parameters. And I am not going to prove this equation. If anyone requires this, please contact us. We have used the term wave function before. Wave function is nothing but a mathematical form of wave and has a mathematical function. But can any mathematical function be used as wave function? The answer is simply no. All mathematical function cannot be used as wave function. The only acceptable mathematical function to be used as wave function are those that correspond to some physical systems. Mathematical requirement to do so is the following condition. That means if psi is a wave function and this is psi xt indicates the position and time dependent wave function. So the wave function must be continuous, finite and single valued, and its first order derivative, that means d psi dx, is also should be continuous, finite and single valued. If this condition holds, then a mathematical function can be used as a wave function. Now what is continuous? Suppose f of x is a function and we want to test whether this is continuous or not. For this I am trying to find the continuity at x equals to a. This is a x running from minus infinity to infinity. So I am writing some limit x tends to a minus f of x equals to limit x tends to a plus f of x equals to f of a. If f of x holds good this condition, then we can say that f of x is continuous. Now what is a minus? You have already know this, but I am telling again. X equals to a is this point and the left side just x equals to a point is known as a minus, and the right side just before the x equals to a is known as a plus. Suppose for more example we can say that we can find the limit at x tends to 10. That means 10 minus indicates 9.999. That means just left of 10 but very close to 10. This may be 9.9999 up to 59 up to 109. How close this is, and this is very important, and this must be less than 10, and 10 plus indicates 10.001. 10.001 is right side of 10 and almost close to 10. If we say that 10 plus equals to 10.0000 up to 10 times 0 and 1, this is very much close to 10. So we can say that 10 plus equals to 10.0001 and 10 minus indicate 9.999, and f of a indicates the value of f of x at x equals to a. So this is continuous. Finite means that wave function has finite value, and single valued means it has only one value for many different of x. That means suppose we have a wave functions like this. Suppose this is a mathematical function, this red one is a mathematical function. That means this is x-axis and this is psi x. So we cannot, if there is any function like this, like the red line, then this cannot be used as wave function, because for a particular x there is more than one value of psi of x. That is why this is not acceptable wave function. Again, this must be finite. What is the indication of finite? Suppose we have a wave function like this. This is x, this is psi x. This is a function like e to the power x. Then what happens for x tends to infinity? E to the power x is finite everywhere, but when we goes to infinity, x tends to infinity, this indicates that e to the power x tends to infinity. But as we said that wave function must be finite, so e to the power x cannot be used as wave function, or otherwise we can say that e to the power x can never be a wave function. This is the finite wave function must be finite at any value of position and time, and you can check any function as continuity from this equation. So now question arises that if if the state of a system consists of only one wave function, no, this may not be the only one wave function which indicates a state or a system. There may be a lot of wave functions, and the wave functions holds good the superposition principle. That means psi equals to sum over of ai psi I, where a goes from I goes from 1 to n, and ai is the weightage of ith state, and psi I is the wave function of individual I functions. Suppose there are two state. Ground state is indicated by wave function psi1, and another state is indicated by wave function psi2, and its weightage is a1 and its weightage is a2. Then total wave function a1 psi1 plus a2 psi2. That means wave function holds the superposition principle. Now the point arises of what are the basic postulates of quantum mechanics. First of all, the state of any physical system is specified at each time t, and the wave function at any time is represented by psi of xt equals to psi x to the power minus I ent by e squared. So let's discuss what is it. Actually, this indicates that if we change the time, we will get the different wave function, different value of wave function. That means we can measure the physical parameters at different time if we know the energy of the system, where En is the energy, and as time varies, wave function varies. That means at a particular time we get only one value of wave function, and if we have the idea about energy and the wave function at t equals to 0, we can find the wave function at later time. Next is every physical measurable quantity which we have already observed, that position, linear momentum, angular momentum, kinetic energy, these are called observable, and this observable corresponds to linear Hermitian operator. We have already observed that every physical parameters can be represented by operator, and they are Hermitian operator. What is Hermitian? Actually, this is analogous to the matrix. Hermitian matrix is defined by A Dagger equals to A. That means if A Dagger equals to A, this is Hermitian. What is Dagger here? Dagger is nothing but the complex conjugate of the transpose, or you can say that transpose of complex conjugate. So in wave function operator algebra, an operator A is called Hermitian if they follows this equation: psi 1 A dagger psi 2 d tau gives us A psi 1 star psi 2 d tau. If this condition holds good for an operator A, then we can say that operator A is Hermitian. But according to the postulates of quantum mechanics, every measurable physical quantity, that is every observables, are Hermitian operator. Third one is the measurement of observable on state provides eigenvalues, which we have already shown that the energy is the eigenvalues of Hamiltonian operator. That means, for an example, we can say that energy is the eigenvalue of Hamiltonian operator. And the fourth one is the idea of probability. When an observable is determined for a particular state, it always provides some probability. For an example, let's consider a wave function psi equals to a1 psi 1 plus a2 psi 2, where psi 1 psi 2 are the wave function of corresponding states, and a1 a2 are the corresponding weightage. Now the probability of finding the particle at state psi 1, this is equals to p, and p is defined by psi 1 star psi d tau divided by psi star psi d tau, and the probability for the state p2, this will gives us psi 2 star psi d tau by psi star psi d tau. These all postulates are very much important. Even if you are solving different type of mathematical problems, this is also important for different types of competitive exam. These four postulates are very much important. We have discussed the wave nature of particle and tried to solve by Schrodinger equation. But is the wave function of electron same as particle? No. Electron cannot be described by a single wave. The wave function of an electron is described by more than one wave having different wavelength, and this is called wave packet. So wave packet is nothing but superposition of a lot of wave function. This wave packet provides the information about both the position and momentum of the object. Here we have shown that two waves propagating along same direction and superpose. After superposing, there they form a sub envelope. This is the envelope they form, shown by blue line, and the orange line is indicates that the superposition of two waves, and this shows that there is some place where the maximum or constructive superposition happens, and there are another place where destructive or destructive of superposition happens. Now the concept of two different velocity arises. One is phase velocity and other is group velocity. The concept of phase velocity and group velocity can be understood well by an example. Suppose there are 50 participants participate in a marathon race. At the time of start of the velocity of all the participants are same, but with the elapse of time the velocity of different participants will be different. Now if you consider the motion of individual participants, you will get an idea of velocity, and this is as phase velocity. And otherwise, if you consider the whole motion of the running group, this will give you another idea of velocity. This is group velocity. So this can be similar, can be applied same as for more than two waves or more than one waves. When they superpose, their individual velocity indicates the phase velocity, and the overall velocity of the group is indicates the group velocity. So now arises the mathematical form, how to describe mathematically the wave packet and the phase velocity and group velocity. Suppose we have a wave function having form like this, that psi xt equals to a e to the power I omega t minus kx, where omega is the angular frequency and k is the propagation vector, and the wave is propagating along x direction. Now the velocity of the wave, this is v equals to omega by k. We can determine the velocity of this wave by the factor inside the exponential term, because omega t and kx unit must be same, so omega t equals to kx, and x by t is the velocity, so velocity is indicated by omega by k, and this velocity is known as the phase velocity. This is phase velocity because this is the velocity of only one wave. Now suppose two waves are propagating along the same direction, having slight change in angular frequency and wavelength, so they can be written as psi 1 xt. This is indicated as a e to the power I omega 1 t minus k1 x, and the second wave is written as psi x to t. This is equals to e to the power I omega 2t minus k to x. Okay, now I am writing that omega equals to omega 1 plus omega 2 by 2 and delta omega equals to omega 1 minus omega by 2. As omega 1 may be greater than omega 2, otherwise omega 2 may be greater than omega 1, so I am putting the mod here, and k similarly k equals to k1 plus k2 by 2 and delta k equals to k1 minus k2 by 2. So from these two equation we can write that omega 1 equals to omega plus delta omega. Adding these two equations, and omega 2 will gives you omega minus delta omega. Similarly k1 equals to k plus delta k and k2 equals to k minus delta k. Now wave function psi1 and psi2 superpose, so as they superpose, so the superposed wave psi can be written as psi1 xt plus psi2 xt. For simplicity I have taken the constant same, so this will gives us e to the power I omega 1t minus k1x plus e to the power I omega 2t minus k2x. That means now I am, what happens, now I am putting the value of omega 1 k1 omega 2 k2 in term of omega delta omega or k and delta k. So this will gives us a to the power I omega t minus kx e to the power I delta omega t minus delta kx e to the power minus I delta omega t minus delta kx. So again we know e to the power I theta plus e to the power minus I theta by 2, this equals to cos theta. So we can write this that a prime e to the power I omega t minus kx cos delta omega t minus delta k into x. So first term indicates the wave and second term indicates the wave packet, because this is consisted of more than one waves. Now from the first term we can write the velocity again. This is phase velocity is indicated by Vp and this is same as omega by k, and the wave packet gives us the velocity about the group velocity, and I am writing the group velocity as Vg. This equals to delta omega by delta k, and if delta omega delta k are very small, that means if omega 1 and omega 2 are almost same, then we can write this d omega tk. These are the two velocity, and these are the corresponding mathematical expression omega by k and d omega by k. This is phase velocity Vp and this is group velocity Vg. More will be discussed in the next class. Please subscribe our channel and comment in the comment box, and for further query please mail us at farsighteach@gmail.com. Thank you.